Hi everyone. Today in this video I want to talk about calculating volume by disk and washer method, module 5 of MTH 1170. So I start with a couple of questions calculating volume by disk and followed by a couple of examples calculate volume by washer. So this is my first example. Find volume by rotating the area between y equal to 2 divided by x and positive x-axis around x-axis from x equal to half to 2. So as you know, there are certain keywords that you need to pay attention to. For example, the area is between which and which function? This function and positive x-axis, and from where to where. This from where to where is going to tell you the limit of your integration. So let me start my calculation. As you know, the first thing it's very important is graphing. So I start graphing this figure first. So let me start graphing by x and y. If x 1 over 2, y will be 4. If x is 2, y will be 2 divided by 2, 1. You may need more points for drawing, but we are interested in the lower limit and upper limit, which is 1 over 2 and 2. We are only interested in these 2 points, the area bounded between these 2 points. So that is 1 over 2. So if you give 1 over 2, it will be 1, 2, 3, 4 here. So this is your first point. Second point, if you give you 2, that is 1, and this is your 2, will be 1. Kind of here. So I need a little, let me give more points. If I give 4, so you have 2 divided by 4 will be half. So that is 4. Say half is here. So it will be somehow here. So I'm new to this explain everything. I changed my software. Sorry if I am slow. I will be quick later on. So I try to say if so let me go, if that is 4, so I need to connect this point. Let me go with green color. So I start from here and then connect these points, this point, this point, and this point. But very interested in is only point 1 over 2 and 2. So if you give 1 over 2 will be here. If you give 2 it will be here. So the area bounded in between, right? So I go for different color, yellow one, and I try to highlight that. So don't forget, if that is 2, this is 1, right? If this is 1 over 2, this is 4. But the area that we are interested in is from 1 over 2 to 2, as the question is suggesting. Okay, so I'm highlighting the area. This is the area between the function, which is y equal to 2 divided by x, the green function, and positive x-axis. So I'm rotating, and you are rotating around y equal to around x-axis. Okay, so it's the first step that you should know where you are rotating and the graphing that you have. So what is the next step? So the next step is trying to which equation I want to use. If you look at the equations, the formula sheet that I distributed the other time in the class, since you are going to calculate volume between revolving this underneath this yellow around x-axis, you are going to use this equation. Volume is equal to pi x equal to a to x equal to b fx square dx. You see that since we're rotating around x-axis, I'm using the volume by disk method. So which everything is with respect to x, no y in this equation. So now you know your lower limit, upper limit, and you know fx. So it's pretty to the point that where the disk method is trying to tell you if you are kind of fitting a disk here. Okay, let me draw my disk better. If that is the disk you are fitting, from the figure to the axis of rotation is the radius of this disk, which is this is radius of the disk, and you see that this is parallel to the y-axis. You're writing y equal to fx, which is thankfully is given to you, which is this one. Okay, so we are going to write the equation of volume. Sorry, this one. This is the pointer. So v is equal to pi integration from 1 over 2 to 2 fx, which is 2x square dx. Okay. So now the rest is just calculating the volume and then go for fundamental theorem to calculate that. So v will be pi integration 1 over 2 to 2 4 x2 dx. That is equal to well, I paused my video to go to the details of a step to speed up a little bit, and then as you saw, the rest of the thing that I did was only fundamental theorem. From here, 4 goes out of the integration, and this x1 divided by x2 became x power minus 2. And you know what's the rule is going to apply here, power rule. So you will end up to this equation 4 pi minus 1 divided by x. Then you need to insert the upper limit 2 inside of the equation and subtract by the lower limit inside the integration, and eventually you end up to a positive number. And you should never forget that your area and volume all the time after integration are positive, and we end up to 6 pi. I want to go for another example. Example 2.